So, we started digging into the amp and got distracted from the reverb tank shown in the part 1 video for this amp. In this part 2 video, let's start by taking a look at the outside of the amp and work our way into the chassis. We're presently looking at the front of the amp. The amp uses a couple of wooden sliders instead of feet. The handles are nice heavy-duty handles, which is good because this amp is pretty heavy. Here's a few more pictures of the amp. Note the red knob where a gray knob should go. Those are some nice looking speakers there. Let's hope they function as nice as they look. Here's a look down into the bottom of the cab. And a bit better look at that very dirty reverb bag. Take note of the model number, model U1040. And here is a glimpse of the chassis, which is mounted directly to the back panel. Look, a gray knob on the back of the amp chassis. Next up, we remove the screws used to hold the back panel to the cab. The transformers in this amp are massive. And last but not least, we get a good look at the back of the speakers. Before taking a look at the chassis, we tested the tubes that came with the amp. The Mullard 6AN8 was leaky on the triode side and tested bad. Both of the Mullard 12AU7 tubes tested good. Two of the Mullard 12AX7 tubes tested leaky and bad on one section. The third Mullard 12AX7 tested good, strong, and both sections matched. A nice vintage tube for sure. The extra Tungsole 12AX7 that came along with the amp tested good and strong on both sections. Two of the RCA 6L6GC tubes tested strong and matched. The third 6L6GC tested strong. The realistic 6L6GC tested in the good range, but it isn't the strongest tube in the world. The four NOS Sylvania 6AN8 tubes all tested good. However, the green label Sylvania 6AN8, to the left, tested very leaky between the cathode and heater. Fortunately, the eBay seller sent a replacement, no questions asked. After the tubes were tested, the chassis was hoisted up on the bench. Note the chassis says U-1011 lead, although the cabinet says U-1040. Notice the rust on two of the tube clips, and also on the two tube sockets. The brown 12AX7 socket to the far right doesn't appear to be an original tube socket. Reverb cable. Filter caps. Here's a couple pictures of the inside of the chassis. Let's get a closer look at the circuit board. Note that the board is labeled U1011. We've traced this circuit board, and the circuit built on this circuit board does not match the Univox U1011 lead schematics that we could find. So, we created a schematic that matches this amplifier. Here's a closer look at the two potentiometers mounted on the circuit board. The C10K on the right is the negative bias pot. Here's a closer look at the filter caps, rectifier diodes, and choke. Here's a pan across the input jacks and potentiometers. All the potentiometer values tested within the 10 to 20% tolerance range and seem to move through their range of values smoothly. So all should be good with the pots. The power switch is a double pull double throw switch. Here are the speaker output jacks. Note the three shunt tip jacks with their shunt tabs nipped off. The Univox U1011 schematic shows speaker jack 1, the jack to the far left in this picture, being a shunt tip shorted to ground, and jacks 2, 3 and 4 being standard non-shunt jacks. This amp has all 4 speaker output jacks wired as standard, non-shunting jacks. Another issue we found was a bad 100 ohm 2-watt resistor we found using a meter and not our eyes. Looking at these two 100 ohm 2-watt resistors, you wouldn't think anything was wrong. But if we spin the upper resistor around, we see the resistor is definitely damaged. Each of these resistors connects the plates of two 6L6GC tubes. Another issue that wasn't immediately visible was found with the blue wire tucked away in the 3-way speaker impedance selector. With the wire pulled out, you can see the wire insulation has been rubbed through to the bare wire by the switch itself, creating a potential short. Notice how dirty the switch contacts are. We decided to remove and clean up the switch. The burnishing tool was used to clean between the double, upper and lower contacts. The only tip I have is to use a small stiff clamp to hold this down and in place while putting the switch back together. It has a spring below it, pushing upwards, that makes it difficult to put the switch back together without something to hold it down. It does pay to look at these amps, even if you're told they work. If you're going to plug in amps without looking at them first, I strongly suggest you use a variac and current limiter. In this picture we started removing the circuit board, which we did before tracing the circuit out and creating a schematic that matches this amp circuit. We've got parts on order, etc. But that's another video.